Hey guys, my name is Talia. I'm a staff member at Discovery and I'm going to help you do your homework today. Okay, so in this question, there's a defendant, and this defendant is either guilty or innocent. And then there's a jury when this person is on trial, this defendant's on trial. The jury has to make a decision about whether or not to acquit or convict this person. Our job in this question is to find out, given that a person is acquitted, were they actually guilty or not? So we're presented with this defendant that, the jury decided to acquit this defendant, but what's the likelihood that that defendant actually was guilty and, is walking free? So to solve this problem, this is a classic Bayes rule question. And we can kind of see this by reading the question. It presents us with a given, and then the conditional probabilities and all that stuff. That's a definite sign for a Bayes rule question. And we're given two separate probabilities, and we have to kind of use these numbers to find other numbers and fill in the entire formula, right? So here we have the probability that the jury was right is 0.9. And so this is actually one probability that encapsulates two different situations. So if a jury was right, that means they acquitted an innocent defendant, right? That's the correct decision. Or they convicted, convicted a guilty defendant. That would also be a correct decision. So we know that both of these things have a probability of 0.9. But then on the contrary, so I'm just going to fill out all the different situations so that we can kind of pull from these probabilities and put them into the formula. And so then on the contrary, if we have a wrong decision, that would be the complement of this, so 1 minus 0.9, that's 0.1. And that would be that a guilty defendant is acquitted or an innocent defendant is convicted, because we don't want those things to happen. That's like the wrong decision. And then we're also given in the question the probability that someone's guilty is 0.7. And this one's a little more simple. This is just the complement of this, the probability that someone's innocent, is 0.3. And that's 1 minus 0.7. And so now we're presented with this question, as I said before, the probability that an acquitted defendant was actually guilty, right? We don't want that to happen, so we want to know what's the likelihood that that would happen. Maybe your first instinct is to say this, but actually it's the other way around, right? Because in this case, we know that the defendant was acquitted, so that would be the given. And so it's not just 0.1. We have to go through Bayes' rule and, find out the probability. So we know the classic Bayes' rule formula. Probability of A given B equals probability of B given A times the probability of A divided by the probability of B, right? So these events A and B, B is the given event. We know B happened. And A, the probability of A depends on whatever happened in B, right? And then we fill out this whole formula to get our final answer. And in this case, we're structuring it as, I'll move over here. We're structuring it as the probability that, you're guilty given that you were acquitted. So, given an acquitted defendant, what's the probability that they were actually guilty? And then, if you format this as Bayes' rule, it would be, you flip them, so probability of acquitted given guilty, this is B given A, times the probability of A, which is guilty in this case, and then divided by the probability of B, which is acquitted. Okay, and if we can find all three of these probabilities and then just plug them in, we have our answer. Sorry for the complications. There weren't many options for filming locations tonight. Anyway, so two of these are pretty easy. Two of these we already found when we were kind of taking our givens and converting them into other things that we can just automatically know from complements and stuff, right? That's the two things on the numerator, we already know those things. And I think the question asked you to format that as a table, which I didn't put it as a table, but this information you would just organize into a table and fill it in. Anyway, so we know that if a guilty defendant is acquitted, that would be a wrong decision on the juror's part, and that would be 0.1. And that's right here, we wrote that out. So we know that this is 0.1, the first term. And then, okay, and then the probability that we're guilty, this was just given straight up in the problem, that's 0.7. So times 0.7 times 0.7. And then the only issue we have left is the probability that you're acquitted. And this wasn't given to us as a number in the problem. And one signal, that's a signal for using the law of total probability, right? Because, well, usually it appears in the denominator of Bayes' rule, especially in this class, that's very common. But also, we have two probabilities that someone's acquitted that are both conditional on something else. And so to find the total probability that somebody is acquitted, that means we have to use the law of total probability, because we weren't given that in the question, right? We were only given that in the context of conditions. And so then we have to find that with a formula. I'm gonna write the formula for that down here. And the probability for that would be okay. So first you have one condition, right? The probability that they're acquitted given that they're guilty. That we know. But then you have to multiply it by the probability that that person is guilty in the first place. This is just the formula for law of total probability. And then you add the other condition, probability that they're acquitted given they're innocent, times the probability that that person is innocent in the first place. One way to visualize this is, I'll draw this here. All right, this is like all defendants, right? This box is all defendants. And I'd say this is the innocent defendants, and this is the guilty defendants. And there's a circle here, this event is that they're acquitted. So this is like all the acquitted people. And then this is guilty and acquitted. And this is innocent and acquitted. And so based on the overall probability that they're guilty in the first place, this box, and then the probability that they're acquitted given their, did I say guilty? Yeah. Probability they're acquitted given they're guilty is this like semicircle. And then this is the probability that they're innocent in the first place. And then this semicircle is the probability that they're acquitted given they're innocent. And then you find these two terms, like this small semicircle is this term, and the big semicircle is this term, and then you add them together to find the total probability of event A. So that's one way I kind of learned how to visualize the law of total probability, and it really helped me understand it. So just wanted to throw that in there. Anyway, the good thing is, moving on, we have all four of these terms that we found originally, right? So acquitted given guilty, this is the wrong decision, that's 0.1. And then the probability that you're guilty, that's given, 0.7. Acquitted given innocent, this is the right decision. If you're innocent, obviously you hope that that person would be acquitted. That's 0.9 given in the question, and then innocent, that's the complement of 0.3. So 0.3. And then adding this up, I got about 0.34. Hopefully, can you still see this down here? 0.34. All right, that's our final number that we need for the formula. Plug that in, put it in a calculator, and I didn't write this one down. 0.1 times 0.7 divided by 0.34 and 0.20588. I don't really know how many digits you're supposed to round to, but pay attention to that. And this is your answer. So the key to this really is to first plan out all your different probabilities based on what you're given. Organize them into a table if you want. I personally don't do that because I don't really care. But you then just get everything, even if you're not going to use it, just plan out everything just in case, especially because you're going to need a lot of terms for this law of total probability. Plug in what you can, solve what you don't have with law of total probability, which is usually the denominator, and then just plug it in, and that's the key. And all Bayes rule questions will be just like this. So if you're stuck on a Bayes rule question that's not this one, you can still refer back to this video for the process and then apply it to different scenarios and different terms and everything.
Slay.